Hey there, welcome to another deep dive. As an LLM expert, I think you're going to really appreciate this one.
Oh, yeah?
Yeah, we're going to be looking at where LLMs and reinforcement learning are kind of coming together.
Cool.
And we've got a ton of sources. We've got some recent papers, even this really interesting overview of RL written in Chinese.
Oh, wow.
Oh, hey there, how can we help?
In the beginning, can we clarify the relation between RL and RLHF?
That's a great question, and it's definitely a key distinction to make, so let's unpack this a bit.
Yeah, it's fundamental to understanding how RL and being applied to LLMs.
Okay, so traditional reinforcement learning, or RL, is about training an agent to make decisions in an environment, right?
That's right. And the agent learns by interacting with that environment and receiving rewards.
Exactly, like, points for winning a game or a penalty for making a wrong move.
The reward signal is usually coming directly from the environment itself, and the goal is for the agent to maximize that reward.
Okay, and where does RLHF fit into all of this?
RLHF, or reinforcement learning from human feedback, it's actually a specialized type of RL.
Oh, okay.
Instead of relying on an environment's reward signal, it uses human preferences as its reward signal.
That makes sense. So instead of a machine giving a score, it's humans who are saying what's good or bad.
Exactly. Humans are basically providing feedback on the quality of the LLM's output.
And the model learns from this human feedback.
Yep. We use that to train a reward model that can evaluate how good a response is.
So RLHF is really about aligning the LLM's behavior with human preferences.
Precisely. It's about teaching it what we find desirable or useful.
Whereas in regular RL, you're just looking for the highest score.
You've got it. Now, this is going to be super important later on as we talk more about reward functions.
Okay, that clarifies a lot. Thanks for asking that. It's a great question, and hopefully that makes our discussion today even more clear.
Yeah, it's a crucial distinction to keep in mind as we move forward.
All right, so we've covered that, and as I was saying earlier, we have some FAQs that bring up like the practical side of all this.
Very cool.
But the thing that really got me, I think, is how like core RL concepts, like exploration versus exploitation.
Right.
They're showing up even with LLMs. That's something I never would have guessed at first. So to walk us through all of this, we've got a real expert in reinforcement learning with us today.
Thanks for having me. Yeah, you're right. The connections go deeper than a lot of people realize.
Okay, so let's dive in. One of the first things that jumped out at me in the material was this idea of world models in RL. The articles talk about how RL agents use these models to do things like predict future states and figure out rewards.
Yeah.
Even use them to guide their exploration. But how does this apply to LLMs?
Well, it's a pretty fascinating parallel when you think about it.
Okay.
An LLM is essentially building a world model of language itself.
Oh, okay.
It's learning about how words relate to each other, concepts, grammar, even style, and it uses that model to generate text, translate languages, and so on.
Gotcha.
It's not a model of the physical world, like in robotics, but the basic principle is similar.
So it's kind of like the LLM is creating a map of how language works, and then using that map to navigate and create new language.
Exactly.
That's really neat.
Yeah, and there are some pretty interesting examples in the RL world that really show the power of this approach.
Okay.
Dreamer, for instance, it uses world models to plan out its actions.
Uh-huh.
It basically imagines different scenarios, and then it chooses the best one to get to its goal. Then you've got MuZero, which goes even further. It learns these models and uses them to master games like chess and Go. But get this. It does this without even knowing the rules.
Oh, wow.
Pretty cool, huh?
Yeah, that's amazing. So we've got these LLMs building their language models.
Right.
But the research actually goes deeper. They're starting to frame the way an LLM talks to a user as sequential decision-making. Which sounds a lot like how RL agents work, right?
It totally does. It's a really clever analogy. Think of it like this. The user's prompt is the state for the LLM.
Right.
The text it generates is its action.
Okay.
And any feedback the user gives, whether it's a thumbs up or even just continuing the conversation, that acts as a reward.
So now we're suddenly looking at things like chatbot conversations through the lens of RL.
Exactly.
That could lead to some really interesting ways to improve those interactions.
For sure. And depending on how the interaction is set up, we can see connections to different RL concepts.
Like what?
Like a single turn, prompt and then response. That might be like a contextual bandit problem.
Uh-huh.
The LLM has to choose the best response out of a bunch of possibilities based on the context, right? But when you get into multi-turn dialogues, well, then we're moving into like full-blown Markov decision processes, MDPs.
Right.
That's when the LLM has to think about the long game. Like, what are the consequences of what it says down the line?
Okay, so now I know there are always challenges when you try to combine different fields like this.
Right.
What are some of the things holding researchers back when it comes to bringing RL and LLMs together?
Well, one of the biggest hurdles is figuring out how to define the reward function.
Hmm.
In a typical RL environment, the reward is pretty straightforward. You win the game, you get points.
Right.
But with LLMs, it's way more subtle.
Okay.
How do you measure the quality of the text it generates? What makes one response better than another? It's a tough nut to crack.
So how are they approaching that challenge? It seems like you'd need a really deep understanding of both language and what humans actually prefer.
Well, one of the most promising approaches is what they call RL-HF reinforcement learning from human feedback.
Okay.
The idea is you train a separate reward model based on, well, what humans like. You collect data on which responses people prefer, and then you use that data to teach the reward model what good looks like.
So instead of trying to hard code what good text is, we're letting the body learn it directly from us.
Exactly.
Makes sense, but it also sounds like it could take a lot of time and effort.
It can. Gathering all that human feedback and annotating it takes time.
Right.
But even a small amount of really high quality feedback can be really valuable in guiding the LLM to create better outputs.
So let's say we've got our reward model all figured out. What are some of the RL algorithms that researchers are using to actually optimize the LLM's policies?
Oh, that's where it gets really interesting. Algorithms like PPO, which stands for Proximal Policy Optimization, and then there's SAC, also known as Soft Actor Critic.
Right.
Those are showing a lot of promise.
Now, SAC is the one that's all about entropy, right? Encouraging exploration.
That's the one.
But how does that apply to an LLM? It's not like it's wandering around a physical maze or something.
That's a great point. It actually goes back to what we were talking about earlier, exploration versus exploitation. You see, an LLM can face a similar dilemma. Does it stick to generating safe, predictable text?
Right.
Or does it take a chance and try something new, something that could be amazing or it could totally flop?
Right.
SAC's focus on entropy can kind of nudge the LLM towards exploring the vast possibilities of language. It might unlock more creative, more unexpected outputs. It's like giving it a little push to be more adventurous with its language.
I like that. So instead of just sticking to the well-worn path,
Right.
it's encouraged to venture out and try new things. And there are probably tons of other RL algorithms out there that could be adapted for LLMs, right?
Oh, absolutely. There's a whole bunch of RL techniques that could be applied here.
Like what? What are some examples?
Well, there's Thompson sampling, for one.
Okay.
That's a classic algorithm for balancing, exploration and exploitation. That could be really interesting for LLMs. Then you've got approaches like Boltzmann exploration and optimistic reward estimation, each with their own, pros and cons.
So are we saying that even the way an LLM learns can be seen through an RL lens? I mean, it's not just about generating text.
Right.
It's also at how it picks up and refines its knowledge, right?
You're exactly right. And some researchers are actually starting to explore the idea of modeling LLM learning as a form of meta learning.
Okay.
Learning to learn.
Meta learning LLMs. That's pretty wild.
It's a complex concept, but the potential is huge.
Well, yeah, I mean, if we're thinking about LLMs as these agents that are always learning and adapting,
Right.
it makes sense to think about how they learn, how to learn.
Exactly. And there are already some really cool hints that this could lead to some big breakthroughs.
Like what?
Well, some researchers have used meta learning to train LLMs that can adapt to new tasks and domains way more effectively. They've seen improvements in, few-shot learning,
Okay.
where the LLM learns new concepts from just a handful of examples,
Right.
and domain adaptation, where it can quickly adjust to a new style or topic.
That's pretty incredible. It's like giving the LLM the ability to pick up new skills on the fly, almost like a human.
That's a great analogy.
Which we have to pause here. We're running into some technical difficulties on our end.